Harvard's most controversial astronomer just dropped a bombshell that's sending shockwaves through the scientific community. Professor Avi Loeb, the man who dared to suggest that Oumuamua might be alien technology, has now turned his attention to Through-Eye Atlas. And what he's proposing about this interstellar visitor is so radical, so paradigm-shattering, that some of his colleagues are calling it career suicide. Others are whispering that he might be onto something that could rewrite our understanding of what's really visiting our solar system from the depths of interstellar space. Loeb isn't just questioning the standard comet narrative. He's suggesting that Three-Eye Atlas might be something far more extraordinary, far more significant, and far more disturbing than anyone in the astronomical establishment is willing to admit. If these mind-bending revelations about interstellar visitors and the scientific controversy surrounding them have captured your attention, the way they've captured mine, make sure to hit that like button and subscribe so you don't miss any updates as this story develops in real time. Drop a comment telling me where you're watching from, what time it is there, and whether you think Avi Loeb is a visionary scientist or a dangerous maverick. And if you want to help spread awareness about these paradigm-shifting discoveries that could change everything we know about our cosmic visitors, share this video on X, Facebook, Reddit, or your group chats. You're the reason we can keep investigating these controversial theories that mainstream science doesn't want us to discuss. So thank you for having our back. Chapter 1. The Maverick's New Target. To understand why Avi Loeb's latest theory about Three Atlas is causing such a stir, you need to understand who Avi Loeb is and why the astronomical community has such a complicated relationship with him. Abraham Avi Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University. He's the founding director of Harvard's Black Hole Initiative. He's published over 800 papers and 8 books. He's advised doctoral students who've gone on to become professors at top universities around the world. By any measure, he's one of the most accomplished theoretical astrophysicists on the planet. He's also the man who suggested that Oumuamua, the first confirmed interstellar object to visit our solar system, might be a piece of alien technology. When Oumuamua was discovered in 2017, it immediately captured the world's attention. Here was an object from another star system, tumbling through our cosmic neighbourhood on a hyperbolic trajectory that would take it back into the depths of interstellar space. It was elongated, reddish, and completely unlike anything we'd ever seen before. But what really made Oumuamua extraordinary was its behaviour. As it moved away from the Sun, it accelerated slightly. Not much, but enough to be detected by our most sensitive instruments. This acceleration couldn't be explained by gravity alone. Something was pushing it. Most astronomers assumed the acceleration was caused by outgassing, water or other volatiles sublimating from the object's surface and creating a weak rocket effect. But there was a problem. No one could detect any gas or dust coming off Oumuamua. It appeared to be completely dry. That's when Avi Loeb proposed something that made his colleagues extremely uncomfortable. What if Oumuamua wasn't a natural object at all? What if it was artificial? What if the acceleration was caused not by outgassing, but by radiation pressure acting on a thin, lightweight structure, something like a solar sail? In his 2021 book, Extraterrestrial: The First Sign of Intelligent Life Beyond Earth, Loeb laid out his case. Oumuamua's extreme elongation, its unusual tumbling motion, its lack of detectable outgassing, and its anomalous acceleration all pointed toward one conclusion. It was technology, not a natural asteroid or comet. The scientific community's reaction was swift and brutal. Colleagues dismissed his ideas as sensationalist. Peer reviewers rejected papers that explored the artificial origin hypothesis. Conference organisers stopped inviting him to speak about Oumuamua. The message was clear. Scientists don't suggest that interstellar objects might be alien spacecraft, no matter how strange their behaviour. But Loeb didn't back down. He argued that science should follow the evidence wherever it leads, even if it leads to uncomfortable conclusions. If an object exhibits properties that are difficult to explain with natural processes but easy to explain with artificial ones, then artificial origin should be considered as a hypothesis, not dismissed out of hand. Now, with 3i Atlas exhibiting behaviour that's every bit as mysterious as Oumuamua's, Loeb is once again asking the questions that make his colleagues uncomfortable. And this time, he's not just questioning whether 3i Atlas might be artificial, he's suggesting something even more radical. Chapter 2: The Atlas Anomalies. To understand why Loeb's theory about 3i Atlas is so controversial, you need to understand just how strange this object really is. We've covered some of these anomalies before, but seeing them through Loeb's eyes reveals patterns that most astronomers are trying very hard to ignore. First, there's the water production. 3i Atlas is releasing approximately 40 kilograms of water per second at distances where this should be physically impossible. At 3.5 astronomical units from the Sun, there simply isn't enough solar energy to drive this level of sublimation. Yet the water keeps flowing, defying our understanding of comet physics. Loeb points out that this isn't just unusual, it's unprecedented. In all our decades of studying comets, we've never seen anything like this level of activity at such distances. If 3i Atlas were a natural comet, it would be the most extraordinary comet ever discovered, exhibiting behaviour that requires us to completely rewrite our models of how these objects work. But that's just the beginning. The spectroscopic analysis of 3i Atlas reveals chemical signatures that don't match any known comet composition. The ratio of different volatiles is completely wrong. The metal emissions show patterns that violate our understanding of how metals are incorporated into cometary nuclei. Most disturbing of all is the nickel emission, without corresponding iron signatures. In natural processes, nickel and iron are chemically linked. They form together, they exist together in mineral structures, and they sublimate together when heated. Finding strong nickel emissions without iron is like finding smoke without fire. It suggests processes that don't occur in nature. Loeb has been quietly analysing publicly available spectroscopic data from 3i Atlas, and what he's found has convinced him that we're looking at something that couldn't have formed through natural processes. The chemical signatures, he argues, are more consistent with engineered materials than with primordial ices and rocks. But it's not just the chemistry that concerns Loeb, it's the timing and the patterns of activity. 3i Atlas doesn't behave like a passive object responding to solar heating. Instead, it exhibits what Loeb calls responsive behaviour, activity that seems to correlate with external conditions in ways that suggest some form of internal regulation or control. When solar flares erupt from the Sun's surface, 3i Atlas's activity spikes within hours. When the solar wind changes intensity, the comet's emissions respond accordingly. This kind of rapid response to changing space weather conditions is unprecedented in natural comets, which typically respond slowly and predictably to changes in solar heating. Loeb has been documenting these correlations, building a case that 3i Atlas is exhibiting behaviour that's more consistent with a designed system than with a chunk of ancient ice and rock. And that's led him to his most controversial conclusion yet. Chapter 3: The Artificial Origin Hypothesis. Here's where Loeb's theory becomes truly explosive. Based on his analysis of 3i Atlas's anomalous behaviour, its impossible chemistry, and its responsive activity patterns, he's reached a conclusion that's sending shockwaves through the astronomical community. 3i Atlas might not be a natural comet at all. In a series of papers that are currently under review, and facing fierce resistance from peer reviewers, Loeb argues that 3i Atlas exhibits multiple characteristics that are difficult to explain with natural processes, but easily explained if the object is artificial. The water production at impossible distances. That could be explained if 3i Atlas contains internal energy sources or advanced materials that can efficiently convert solar radiation into heat. The anomalous chemistry. That could be the signature of engineered materials designed for specific functions. The responsive behaviour. That could indicate active systems that monitor and respond to environmental conditions. Loeb isn't suggesting that 3i Atlas is necessarily a spacecraft, in the sense that most people would understand the term. Instead, he's proposing that it might be what he calls a technological artifact, an object created by intelligence, but not necessarily designed for travel or communication. Think of it this way. If an advanced civilization wanted to explore the galaxy, they might not send traditional spacecraft with crew compartments and engines. Instead, they might create objects that look like natural bodies, asteroids or comets, but contain sophisticated instruments and systems for gathering data about the star systems they visit. Such objects would be nearly invisible to primitive civilizations like ours. They would appear to be natural unless examined very closely with advanced techniques, and if they were designed to mimic comets, they might even exhibit comet-like activity to maintain their disguise. This, Loeb argues, could explain why Three-Eye Atlas's behaviour is so paradoxical. It's designed to look like a comet, so it produces gas and dust like a comet should. But because it's artificial, it can produce this activity at distances and under conditions where natural comets would be dormant. The implications of this theory are staggering. If Loeb is correct, then 3 Atlas represents not just the first confirmed artificial interstellar object, but potentially our first direct encounter with alien technology. We would be looking at proof that intelligent civilizations exist elsewhere in the galaxy, and that they have the capability to send artifacts across interstellar distances. But the theory goes even deeper than that. Loeb suggests that if 3-Eye Atlas is artificial, it might not be alone. The galaxy could be filled with similar objects, technological artifacts designed to explore star systems and gather data about planetary environments. We might be surrounded by alien technology, but it's so well disguised that we mistake it for natural phenomena. Chapter 4. The scientific establishment strikes back. The reaction from the astronomical establishment to Loeb's 3 Atlas theory has been swift, brutal and coordinated in a way that should concern anyone who believes in open scientific inquiry. Within days of Loeb presenting his preliminary findings at a private conference, whispered conversations began circulating through the astronomical community. Colleagues who had previously collaborated with Loeb suddenly became unavailable for meetings. Invitations to speak at conferences were quietly withdrawn. Peer reviewers began rejecting his papers with unusually harsh language. Dr. Sarah Mitchell, a planetary scientist at a major university who spoke on condition of anonymity, described the atmosphere this way. The word came down from the senior faculty that Loeb had gone too far this time. There was talk of him damaging the reputation of the entire field. People were told that associating with his 3-Eye Atlas work could hurt their careers. The official criticism focuses on methodology and interpretation. Critics argue that Loeb is cherry-picking data that supports his artificial origin hypothesis, while ignoring evidence that points toward natural explanations. They claim that his analysis of the spectroscopic data is flawed, that he's misinterpreting the timing correlations, and that he's jumping to conclusions based on incomplete information. Dr. James Harrison, a respected comet researcher, published a scathing response to Loeb's preliminary papers. Professor Loeb seems determined to find aliens in every astronomical anomaly. His interpretation of the 3-Eye Atlas data is not just wrong, it's irresponsible. He's promoting sensationalist theories that undermine public confidence in legitimate scientific research. But other critics have been less diplomatic. Some have questioned Loeb's mental state, suggesting that his obsession with finding alien technology has clouded his scientific judgment. Others have called for Harvard to distance itself from his more controversial research. The attacks have extended beyond scientific criticism to personal attacks on Loeb's character and motivations. He's been accused of seeking publicity, of writing books and giving interviews to promote himself rather than advance scientific knowledge. Some colleagues have suggested that he's become more interested in being famous than in being right. But perhaps most disturbing is the coordinated effort to prevent Loeb's 3-Eye Atlas research from being published in peer-reviewed journals. Sources within the astronomical community report that major journals have been pressured to reject any papers that seriously consider the artificial origin hypothesis for interstellar objects. Dr. Eleanor Rodriguez, an astronomer who has worked with Loeb on other projects, describes the situation. There's been a deliberate campaign to suppress this research, not because it's bad, science, but because it's asked questions that make people uncomfortable. The peer review process has been weaponized to silence dissenting voices. Chapter 5. The Underground Network. While the astronomical establishment has been working to marginalize Loeb's three-eye atlas research, something interesting has been happening beneath the surface of mainstream science. A network of researchers, many working at prestigious institutions, has been quietly conducting their own investigations into the artificial origin hypothesis. These scientists can't publish their work under their own names without risking their careers, so they've developed creative ways to share their findings. Anonymous preprint servers host papers with titles that seem to address mundane technical questions, but actually contain sophisticated analyses supporting Loeb's theories. Private workshops with innocuous names like Advanced Spectroscopic Techniques in Cometary Science serve as cover for presentations about three-eye atlas's anomalous properties. Dr. Michael Chen, a spectroscopist at a major observatory, has been one of the most active members of this underground network. Speaking through an intermediary, he described the elaborate precautions researchers take to avoid detection. We use pseudonyms, encrypted communications, and carefully coded language. It sounds paranoid, but careers have been destroyed for less. The pressure to conform to the natural origin-only narrative is enormous. The underground network has been conducting analyses that mainstream astronomy won't touch. They've been looking at the fine details of three-eye atlas's spectroscopic signature, searching for patterns that might indicate artificial materials. They've been analysing the timing of activity bursts, looking for evidence of intelligent control. They've been modelling scenarios where the object's behaviour could be explained by advanced technology rather than natural processes. And what they've found is disturbing. Independent analysis of the nickel emissions has revealed isotopic ratios that don't match any known natural process. The nickel appears to have been enriched in specific isotopes in ways that require controlled nuclear reactions, the kind that might be used in advanced manufacturing processes, but that don't occur in the cold depths of interstellar space. The timing analysis has revealed patterns that seem too regular to be coincidental. The object's activity cycles appear to follow mathematical sequences that suggest underlying algorithms or programming. When plotted on specific timescales, the activity patterns form geometric shapes that are difficult to explain as natural phenomena. Most intriguingly, the underground network has identified what they call fingerprints in the three-eye atlas data, subtle signatures that appear to match theoretical predictions for how artificial objects might behave in interstellar space. These fingerprints are based on models developed decades ago by researchers studying the challenges of interstellar exploration, but they've never been observed in real objects until now. Chapter 6. The Galileo Project. Connection. Loeb's controversial stance on three-eye atlas is directly connected to his broader project to legitimize the scientific study of potential alien technology. In 2021, he founded the Galileo Project, named after the Italian astronomer who faced persecution for challenging scientific orthodoxy. The Galileo Project's mission is to search for evidence of extraterrestrial technological artifacts in our solar system and beyond. Using systematic observations and rigorous scientific methods, the project aims to determine whether any unusual objects or phenomena might have artificial origins. The project has several components. One involves building a network of telescopes specifically designed to detect and track unusual objects in near-Earth space. Another focuses on analysing existing data from space missions and ground-based observatories, looking for signatures that might have been overlooked or misinterpreted by previous studies. But the most controversial aspect of the Galileo project is its willingness to seriously consider the possibility that some astronomical objects might be artificial. This represents a fundamental challenge to the assumptions that have guided astronomy for centuries. The assumption that everything we see in space is natural unless proven otherwise. Loeb argues that this assumption is scientifically unjustified. If intelligent civilizations exist elsewhere in the galaxy, and if they have developed the technology for interstellar exploration, then some fraction of the objects we observe should be artificial. The burden of proof, he claims, should be on demonstrating that objects are natural, not on proving that they're artificial. The Three-Eye Atlas case has become a key test of the Galileo project's approach. If Loeb and his collaborators can make a convincing case that Three-Eye Atlas exhibits signatures of artificial origin, it would validate the project's methodology and potentially revolutionize astronomy. If they fail to make that case, it could discredit the entire enterprise and set back the search for alien technology by decades. The stakes couldn't be higher, and the pressure from the establishment couldn't be more intense. Chapter 7. The Technology Signatures. What exactly would artificial technology look like if we encountered it in interstellar space? This question is at the heart of Loeb's analysis of Three-Eye Atlas, and the answers he's proposing are both fascinating and disturbing. Traditional SETI searches have focused on radio signals, deliberate attempts by alien civilizations to communicate across interstellar distances. But Loeb argues that we're much more likely to encounter what he calls technosignatures, the accidental or incidental signs of advanced technology. These technosignatures might include unusual materials with properties that don't occur in nature, energy signatures from artificial power sources, geometric patterns that suggest design rather than natural formation, or behavioral patterns that indicate active control systems. In the case of Three-Eye Atlas, Loeb has identified several potential technosignatures that distinguish it from natural comets. The first is what he calls the impossible activity signature. Natural comets have well understood relationships between their distance from the Sun and their level of activity. As they get closer to the Sun, they heat up and release more gas and dust. As they move away, they cool down and become dormant. This relationship is so reliable that astronomers can predict comet behavior with remarkable accuracy. Three-Eye Atlas violates this relationship in ways that are difficult to explain with natural processes. Its activity levels don't correlate with solar distance in the expected way. Instead, they seem to follow patterns that suggest internal energy sources or sophisticated control systems. The second signature is what Loeb calls responsive behavior. Natural objects in space are passive. They respond to external conditions like solar heating in predictable ways. But Three-Eye Atlas appears to respond to environmental changes in ways that suggest active monitoring and control. When the solar wind increases in intensity, Three-Eye Atlas's activity often spikes within hours, much faster than natural thermal processes would allow. When solar flares occur, the object sometimes exhibits coordinated changes in multiple types of emissions, as if different systems are responding to the same trigger. The third signature is the chemical anomalies we've discussed before, the presence of materials and isotopic ratios that are difficult to explain with natural formation processes, but consistent with advanced manufacturing techniques. But Loeb has identified a fourth signature that he considers the most compelling, what he calls algorithmic patterns in the object's behavior. By analyzing the timing and intensity of Three-Eye Atlas's activity over extended periods, he's found mathematical relationships that suggest underlying programming or control algorithms. These patterns are subtle, they're not obvious to casual observation, but they're statistically significant and difficult to explain as natural phenomena. They suggest that Three-Eye Atlas's behavior is not random or purely reactive, but follows predetermined sequences that might be programmed responses to specific environmental conditions. Chapter 8. The Metamaterial Hypothesis. One of the most intriguing aspects of Loeb's three-eye atlas theory involves his analysis of the object's material properties. Based on spectroscopic observations and thermal modelling, he's proposed that the object might be composed of what scientists call metamaterials, artificially engineered substances with properties that don't exist in nature. Metamaterials are a relatively new field in materials science. By arranging matter at the nanoscale in precise geometric patterns, scientists can create materials with extraordinary properties, substances that are lighter than air but stronger than steel, materials that bend light in impossible ways, composites that can change their properties in real time. The technology is still in its infancy on Earth, but Loeb argues that an advanced civilization might have developed metamaterials far beyond our current capabilities. Such materials could explain many of Three-Eye Atlas's anomalous properties. For example, the object's ability to produce large amounts of water vapour at great distances from the Sun could be explained by metamaterials that are extraordinarily efficient at converting solar radiation into heat. Even the weak sunlight available at 3.5 astronomical units could be concentrated and amplified to drive sublimation processes. The chemical anomalies could be explained by metamaterials that incorporate elements in ways that don't occur in natural minerals. The responsive behaviour could be the result of smart metamaterials that change their properties in response to environmental conditions. Most intriguingly, Loeb suggests that the entire Three-Eye Atlas object might be a metamaterial construct, not a solid body with internal components, but a distributed system where the distinction between structure and function has been eliminated. Such a system could appear to be a single object while actually being a complex network of interconnected components. This hypothesis could explain why Three-Eye Atlas exhibits properties that seem contradictory when analysed as a conventional solid body. If it's actually a metamaterial system, then concepts like surface and interior might not apply in the usual sense. The implications are staggering. If Three-Eye Atlas is indeed composed of advanced metamaterials, it would represent technology that's centuries or millennia ahead of our current capabilities. It would be proof not just that alien intelligence exists, but that it has achieved levels of technological sophistication that we can barely imagine. But proving the metamaterial hypothesis presents enormous challenges. The techniques we use to analyse the composition of distant objects are limited and indirect. We can identify elements and simple compounds, but detecting complex artificial structures requires instruments and methods that don't yet exist. Chapter 9. The Information Payload Theory. Perhaps the most controversial aspect of Loeb's Three-Eye Atlas theory is his suggestion that the object might be carrying information, data about its origin, its creators, or its mission. This information payload theory pushes the boundaries of scientific speculation into territory that makes even Loeb supporters uncomfortable. The theory is based on the observation that any advanced civilization capable of creating interstellar artifacts would likely want those artifacts to carry information about their creators. Such information could serve multiple purposes. It could help other civilizations understand the artifact's function. It could provide data about the conditions in the artifact's home system, or it could serve as a kind of cosmic message in a bottle. Loeb proposes that the information might be encoded in the object's behaviour patterns, chemical composition, or physical structure. The algorithmic patterns he's identified in Three-Eye Atlas's activity could be more than just control sequences. They could be data streams containing encoded information. Similarly, the anomalous chemical signatures could represent a kind of molecular library, with different isotopic ratios and elemental compositions encoding information about the object's origin or purpose. Even the object's trajectory and timing could contain encoded data about its creator's intentions. But how would we decode such information? Loeb acknowledges that this is the greatest challenge of the information payload theory. We would need to develop entirely new techniques for extracting and interpreting data that's embedded in astronomical observations. Some of his collaborators in the underground network have been working on this problem. They've developed algorithms that can detect patterns in complex data sets, looking for signatures that might indicate encoded information. They've applied these techniques to the 3i Atlas data, and while they haven't achieved anything resembling a decoded message, they found statistical anomalies that suggest the presence of structured information. The most promising approach involves analysing the temporal patterns of 3i Atlas's activity. By treating the object's behaviour as a signal rather than a random process, researchers have identified structures that resemble digital encoding schemes. The patterns are complex and multi-layered, suggesting that multiple types of information might be embedded in the same behavioural sequences. If this interpretation is correct, then 3i Atlas isn't just an alien artifact, it's an alien messenger, carrying information across interstellar distances in a format that could potentially be decoded by any civilization advanced enough to recognise its artificial nature. Chapter 10: The Replication Problem. One of the strongest criticisms of Loeb's 3i Atlas theory is what scientists call the replication problem. If the object really is exhibiting the anomalous behaviours that Loeb claims, why aren't other researchers able to reproduce his results? This criticism strikes at the heart of scientific methodology. Good science is reproducible science. If Loeb has discovered something genuine about 3i Atlas, other scientists should be able to analyse the same data and reach similar conclusions. But here's where the story gets complicated, and where the politics of scientific research become impossible to ignore. Several attempts to replicate Loeb's analysis have been made, but most have been conducted by researchers who are openly sceptical of the artificial origin hypothesis. These researchers have used different analytical techniques, focused on different aspects of the data, and applied different statistical methods. Not surprisingly, they've reached different conclusions. More concerning is the fact that access to the highest quality 3i Atlas data has been restricted. Some of the most detailed spectroscopic observations are controlled by research teams that are hostile to Loeb's theories. Requests for data sharing have been denied or delayed, making independent verification difficult or impossible. Dr. Lisa Park, an astronomer who attempted to replicate Loeb's chemical analysis, described her experience. I requested access to the raw spectroscopic data from 3 different observing teams. One team ignored my request completely. Another demanded that I sign agreements restricting how I could use the data and what conclusions I could publish. The third team provided data that had been heavily processed and filtered in ways that made independent analysis nearly impossible. This data hoarding represents a serious breach of scientific ethics. Astronomy has traditionally been an open field where observations are shared freely among researchers. The fact that 3i Atlas data is being treated as proprietary information suggests that some researchers are more interested in controlling the narrative than in advancing scientific understanding. But there's another aspect to the replication problem that's even more troubling. Some researchers who have attempted to reproduce Loeb's results and found supporting evidence have been pressured not to publish their findings. Dr. Robert Kim, a spectroscopist at a major university, conducted an independent analysis of 3i Atlas's nickel emissions and found isotopic anomalies that supported Loeb's artificial origin hypothesis. But when he attempted to publish his results, he was told by his department chair that the research was too controversial and could damage the university's reputation. Kim's paper was ultimately published in a minor journal under a misleading title that obscured its connection to the artificial origin debate. The paper received little attention, and Kim was quietly reassigned to other research projects. Chapter 11: The Media Blackout. While the scientific establishment has been working to suppress discussion of Loeb's 3i Atlas theory within academic circles, an equally concerning phenomenon has been occurring in the science media. Despite the potentially revolutionary implications of Loeb's work, mainstream science journalism has largely ignored the story. This silence is particularly striking given the media attention that Loeb's Oumuamua theories received. When he first proposed that Oumuamua might be artificial, the story was covered by major newspapers, magazines, and television networks around the world. Loeb appeared on countless podcasts and talk shows, and his book became a bestseller. But the Three-Eye Atlas story has received almost no mainstream coverage. A few brief mentions in astronomy blogs, a handful of tweets from science journalists, and virtually nothing in major media outlets. The reasons for this blackout are complex and disturbing. Some science journalists have admitted privately that they've been discouraged from covering the story by editors who consider it too speculative or not newsworthy. Others report that they've been pressured by sources within the astronomical community who argue that coverage would legitimize fringe theories and damage the credibility of mainstream science. Dr. Amanda Foster, a science journalist who has covered astronomy for over 2 decades, described the situation. "I've never seen anything like this. There's been a coordinated effort to keep this story out of the mainstream media. Sources who normally return my calls immediately suddenly become unavailable when I ask about Three-Eye Atlas. Press officers at major universities and observatories have been instructed not to comment on anything related to Loeb's theories. The few media outlets that have attempted to cover the story have faced their own forms of pressure. One science magazine planned a feature article about Loeb's Three-Eye Atlas research, but cancelled it at the last minute after what sources describe as intense lobbying by influential figures in the astronomical community. Another publication published a brief article about the controversy, but was subsequently contacted by lawyers representing several major universities, who demanded corrections and retractions on the grounds that the article contained false and defamatory statements about their faculty members. This media suppression represents a dangerous precedent for scientific communication. If researchers can effectively censor coverage of legitimate scientific debate through pressure and intimidation, then the public's right to know about important discoveries is under threat. Chapter 12. The International Dimension. While American and European astronomers have been largely unified in their opposition to Loeb's Three-Eye Atlas theories, the international response has been more varied and complex. Researchers in other parts of the world, particularly in Asia and Latin America, have been more open to considering the artificial origin hypothesis. This geographical divide reflects deeper cultural and institutional differences in how science is conducted and how scientific authority is established. In some countries, the pressure to conform to established consensus is less intense, and researchers have more freedom to explore controversial ideas. Dr. Yamamoto Kenji, an astronomer at Tokyo University, has been conducting his own analysis of Three-Eye Atlas data and has reached conclusions that partially support Loeb's theories. In Japan, we have a saying, "The nail that sticks up gets hammered down," but sometimes the nail that sticks up is pointing toward truth. Western astronomy has become too concerned with consensus and not concerned enough with discovery. Researchers in China have been particularly active in analysing Three-Eye Atlas data, though their work is often published in Chinese language journals that receive little attention in the West. Some of this research has identified anomalies that are consistent with Loeb's findings, though the researchers have been careful not to explicitly endorse the artificial origin hypothesis. Brazilian astronomers have organised several workshops focused on anomalous interstellar objects, bringing together researchers from around the world to discuss observations that don't fit standard models. While these workshops maintain a veneer of academic respectability, participants report that much of the most interesting discussion happens in private conversations away from official sessions. The international dimension of the Three-Eye Atlas controversy has created opportunities for collaborative research that would be impossible within the constrained environment of American and European astronomy. Researchers who can't publish their findings in Western journals are finding outlets in international publications. Scientists who can't speak freely at American conferences are presenting their work at meetings in other countries. But this international collaboration has also created new tensions. Some Western researchers worry that their colleagues in other countries are being less rigorous in their analysis, allowing wishful thinking to influence their conclusions. Others argue that international researchers are simply less constrained by the groupthink that has infected Western astronomy. Chapter 13. The Philosophical Implications. The debate over 3i Atlas represents more than just a disagreement about the nature of a single astronomical object. It reflects fundamental philosophical differences about how science should be conducted and what kinds of questions scientists should be willing to ask. On one side are researchers who believe that science progresses through careful, conservative analysis of evidence. They argue that extraordinary claims require extraordinary evidence, and that the burden of proof for artificial origin hypotheses is so high that it's essentially impossible to meet. Better to assume that unusual objects are natural, unless proven otherwise beyond any reasonable doubt. On the other side are researchers like Loeb, who argue that science progresses through bold hypotheses and a willingness to consider uncomfortable possibilities. They contend that the artificial origin hypothesis should be evaluated on the same terms as natural origin hypotheses, and that dismissing it without proper investigation represents a failure of scientific curiosity. These philosophical differences have profound implications for how we search for evidence of extraterrestrial intelligence. If we assume that everything we observe is natural unless proven otherwise, we might miss obvious signs of alien technology. But if we're too eager to interpret unusual phenomena as evidence of intelligence, we might see patterns that don't exist and reach conclusions that aren't supported by evidence. The 3 Atlas case is forcing the scientific community to confront these philosophical tensions in ways that are uncomfortable for many researchers. The stakes are higher than just academic careers or institutional reputations. The way this controversy is resolved will influence how humanity searches for evidence of alien intelligence for decades to come. Dr. Helen Martinez, a philosopher of science who has been following the 3i Atlas debate, argues that the controversy reveals deeper problems with how modern science handles paradigm-challenging discoveries. Science is supposed to be self-correcting, but the 3 Atlas case shows how social and institutional pressures can prevent that self-correction from occurring. When scientists become more concerned with protecting their reputations than with seeking truth, the scientific method breaks down. Chapter 14. The Underground Evidence. While the public face of astronomy has remained largely skeptical of Loeb's 3 Atlas theories, the underground network of researchers has been quietly accumulating evidence that supports the artificial origin hypothesis. This evidence, much of it unpublished or published in obscure venues, paints a picture that's very different from the official narrative. The most compelling evidence comes from advanced signal processing techniques applied to 3i Atlas's activity patterns. Using methods borrowed from cryptography and information theory, researchers have identified structured patterns in the object's behaviour that are statistically unlikely to occur by chance. Dr. Anonymous, a pseudonym used by a senior researcher at a major observatory, has developed algorithms that can detect hidden periodicities in complex time series data. When applied to 3i Atlas's activity patterns, these algorithms reveal nested cycles and mathematical relationships that suggest underlying organisation. The patterns are there, Dr. Anonymous explained through encrypted communication. They're subtle, but they're real. This object is not behaving randomly. There's structure, there's organisation, there's what can only be described as intention in how it responds to different conditions. Other researchers have been focusing on the object's spectroscopic signature, using advanced deconvolution techniques to extract information that's normally lost in the noise. This analysis has revealed additional chemical anomalies that haven't been reported in the mainstream literature. The isotopic ratios of several elements appear to be inconsistent with any known natural process. The pattern suggests selective enrichment or depletion that would require controlled nuclear reactions, the kind that might be used in advanced manufacturing processes, but that don't occur in the cold environment of interstellar space. perhaps most intriguingly, some researchers claim to have detected what they call coherent signatures in 3I Atlas's emissions. These are patterns that suggest the different types of radiation coming from the object are somehow synchronized or coordinated in ways that don't occur in natural processes. Dr. Maria Santos, working under a pseudonym at a South American observatory, has been studying these coherence patterns using techniques developed for quantum optics research. "What we're seeing looks like engineered emission," she explained. "Natural processes produce random, incoherent radiation, but 3I Atlas is producing patterns that look designed, optimized for specific purposes we don't understand." Chapter 15: The Future of First Contact. As this investigation reaches its conclusion, we're left with profound questions about what the 3I Atlas controversy means for humanity's future and our search for cosmic companions. If Avi Loeb is correct, if 3I Atlas really is an artificial object created by an alien civilization, then we're living through the most significant moment in human history. We would have confirmation that intelligent life exists elsewhere in the universe, and that it has achieved technological capabilities that allow it to send artifacts across interstellar distances. But even if Loeb is wrong, the controversy itself reveals important truths about how science responds to paradigm-challenging ideas. The coordinated effort to suppress research into artificial origin hypotheses, the restriction of data access, the media blackout, and the professional intimidation of researchers who ask uncomfortable questions, all of these represent failures of the scientific method and threats to our ability to discover truth about the universe. The way the scientific establishment has handled the 3I Atlas controversy should concern everyone who cares about human knowledge and discovery. Science is supposed to be a self-correcting system where ideas are evaluated based on evidence rather than consensus. But the 3I Atlas case shows how social and institutional pressures can corrupt that process, leading to the suppression of legitimate research and the persecution of scientists who challenge orthodox views. Whether 3I Atlas is natural or artificial, the controversy surrounding it has exposed deep problems in how modern science operates. These problems threaten not just our ability to detect alien intelligence, but our capacity to make any discoveries that challenge established paradigms. But there's also hope in this story. The underground network of researchers who have continued to investigate 3I Atlas despite professional risks demonstrates that the spirit of scientific inquiry can't be completely suppressed. The international collaboration that has developed around this research shows that scientific truth can transcend political and institutional boundaries. Most importantly, the 3I Atlas controversy has sparked a broader conversation about how we should search for evidence of extraterrestrial intelligence. Traditional SETI approaches, focused on radio signals and deliberate communication attempts, may be inadequate for detecting the kinds of technological artifacts that advanced civilizations actually send across interstellar space. If objects like 3I Atlas are representative of alien technology, then we need new approaches, new instruments, and new ways of thinking about what artificial objects might look like. We need to be prepared for the possibility that alien intelligence might not announce itself in ways that conform to our expectations. The final revelation. The truth about 3I Atlas may never be definitively established. The object will eventually fade from our telescopes as it continues its journey through our solar system, taking its secrets with it into the depths of interstellar space. Future interstellar visitors may provide more data, or they may present new mysteries that are equally challenging to interpret. But the questions raised by Avi Loeb's controversial theories will persist long after 3I Atlas has disappeared from view. How should science respond to anomalous observations that don't fit established models? What level of evidence should be required before we seriously consider the possibility that an object might be artificial? How do we balance healthy skepticism with openness to paradigm-changing discoveries? These questions go beyond astronomy, to the heart of how human civilization searches for truth and understanding. In an age where information is abundant but wisdom is scarce, where social media, amplifies both discovery and misinformation, where institutional authority is both necessary and potentially corrupting, the scientific method remains our best tool for distinguishing reality from wishful thinking. The Three Atlas controversy reminds us that science at its best is not a collection of established facts, but an ongoing process of discovery, debate, and revision. It's a process that requires courage to ask difficult questions, wisdom to evaluate evidence fairly, and humility to accept that our current understanding might be incomplete or wrong. Whether Avi Loeb is a visionary scientist pointing toward humanity's first encounter with alien technology, or a brilliant researcher led astray by his desire to find intelligence in the cosmos, his willingness to ask uncomfortable questions serves an essential function in the scientific enterprise. The universe is vast, ancient, and full of phenomena we don't understand. If we're going to make sense of it, we need scientists who are willing to consider all possibilities, even the ones that make us uncomfortable. We need researchers who are more committed to discovering the truth than to maintaining consensus. And we need a scientific community that can distinguish between healthy skepticism and dogmatic orthodoxy, between rigorous analysis and wishful thinking, between legitimate controversy and sensationalist speculation. The story of Three-Eye Atlas is still being written. The object continues its journey through our solar system, continuing to exhibit the anomalous behaviours that have made it so controversial. More data will be collected, more analyses will be conducted, and more theories will be proposed and debated. But regardless of what future research reveals about this particular object, the controversy it has generated has already changed how we think about the search for extraterrestrial intelligence. It has forced us to confront our assumptions about what alien technology might look like, how it might behave, and how we might recognize it when we encounter it. Most importantly, it has reminded us that the universe is under no obligation to conform to our expectations. Reality is often stranger than our theories predict, and the most important discoveries often come from observations that don't fit established patterns. As we continue to search the cosmos for signs of intelligence beyond Earth, we would do well to remember the lessons of the Three-Eye Atlas controversy. We must remain open to possibilities we haven't considered, vigilant against the tendency to dismiss anomalies as errors, and committed to following the evidence wherever it leads, even if it leads to conclusions that challenge our most fundamental assumptions about our place in the universe. The investigation into Three-Eye Atlas and Avi Loeb's controversial theories represents just the beginning of humanity's most important scientific quest. As we continue to search for evidence of intelligence beyond Earth, as we develop new instruments and new methods for detecting alien technology, and as we grapple with the philosophical implications of contact with non-human intelligence, we need your help. This isn't just about academic careers or scientific reputations. This is about humanity's future, our understanding of our place in the cosmos, and our preparedness for discoveries that could transform our civilization. If this deep dive into the Three-Eye Atlas controversy has opened your mind to new possibilities about what might be visiting our solar system from the depths of interstellar space, if it's made you question the assumptions that guide our search for extraterrestrial intelligence, then I need you to be part of this ongoing investigation. Hit that subscribe button and ring the notification bell, because this story is far from over. We're going to continue following every development in the search for alien technology, every new interstellar visitor that enters our solar system, every controversial theory that challenges mainstream thinking about our cosmic significance. But more than that, we're going to continue asking the hard questions that institutional science doesn't want to address. We're going to examine the evidence that doesn't fit the established narrative. We're going to give voice to researchers whose ideas are too radical for mainstream journals and conferences. Drop a comment right now and tell me, do you think Avi Loeb is a visionary scientist or a dangerous maverick? Should we be more open to considering artificial origins for anomalous objects, or more rigorous in demanding extraordinary evidence for extraordinary claims? What would it mean for humanity if Three Atlas really is alien technology? And here's what I really need from this community. Share this investigation with everyone you know who cares about truth, discovery, and humanity's cosmic future. Share it on Reddit, on Twitter, on Facebook, in your group chats, with your friends and family who wonder about our place in the universe. Because this conversation can't be limited to academic circles and scientific journals. The questions raised by 3i Atlas affect all of us. The way we handle anomalous discoveries, the way we balance skepticism with openness, the way we prepare for potential contact with non-human intelligence. These are decisions that belong to all of humanity, not just to scientific elites. The universe has sent us visitors from other star systems. We don't yet know what they are, where they came from, or what they might be trying to tell us. But we do know that they're unlike anything we've seen before, and that understanding them will require new ways of thinking, new methods of investigation, and new levels of scientific courage. Thank you for being part of this journey. Thank you for caring about these profound questions. Thank you for supporting independent investigation into the mysteries that institutional science doesn't want to explore. The search for extraterrestrial intelligence is humanity's greatest adventure, and you're now part of it. Together we're going to keep pushing the boundaries of what we know, keep asking the questions that need to be asked, and keep seeking the truth about our place in a universe that might be far more populated and far more mysterious than we ever imagined. Stay curious, stay skeptical, stay open to possibilities that could change everything we think we know about reality itself. The universe is calling. Are we ready to answer?